Right, hello everybody. I'm going to give you a brief overview of what little I know of the RPM system. It's going to be a bit of a sing-out type of operation. I don't know really who I'm talking to, what sort of level any of you are. So if I'm going too fast, too slow, don't sing out, shout, and we'll modify. I'll wing it. It'll all happen fine. That's slower than my machine. Okay. What I'm going to look at really is reasons why we bother with package management in the first place. I'm going to look at how you deal with. Client's busy scribbling. It's not very accurate, client. How we manage binary RPMs, which is what most people do most of the time. Then I'm going to go a bit further into scriptlets. I need to go a little bit further. RPM, how we all have heard of. So we'll talk a bit about that.
Suppose you think of us.
It is. That's basically what my slide says. And then we're going to go off into source RPMs, which you will use because they're great. So, the first thing, my animation is about to fail in a big way, is why do we bother packaging a tool? Why do we bother with this overhead? Why do we have to learn about this new tool? Well, it's not that new now. Why do we have to learn about a tool when all we need to do is put files in place? No, don't do that. Very good. Sorry. First and foremost, we use packages just to bundle our files together. You can end up with an awful lot of files in an awful lot of places. Particularly as file systems become more standard, you have to split your package between lots of different places on your disk. So rather than getting everything confused, we can just tag them to say where they belong to. So we can manage a whole package as one entity rather than as 25 zillion files. That has an enormous effect when upgrading, particularly. If you want to upgrade one package to the next version, you've got to make sure you've got all the old stuff out to put all the new stuff in. So if you can talk about it as a single piece of kit, a single item, upgrade is a lot easier. It also minimises the risk of feral files. Usually when a piece of kit's been running for a while, there'll be a number of files on the file system that nobody knows what they are, who they belong to, why they're there, what they do. If we're fairly disciplined about use of packages, then you can query the package database. You can say who owns this file, what is it? And the package database can tell you where it came from. So that'll give you a good idea as to why it's there and if you still want it. Dependency is an important system. One of the really nice things about a GNU or Linux system is that it is heavily modular. You can chop and change little tiny pieces of it, and you build structures out of many of these modules. That obviously means that one module will often have a certain requirement. It'll need this other module, and it may need this version of this other module. So with a package system, you can keep track of that. You can find out what it provides, you can find out what it needs, and you can work out whether this set of modules will work together. There's packages to help with when you come to install a piece of kit, install a module rather. Rather than just copying files in place, there's often a lot more to be done as part of the installation, and you can do that with a package management system. It makes it a lot easier. We'll come back to that. No? Yes. Simple management of binaries. This is what most people use RPMs for. They download a piece of binary off a website somewhere and install it in Hampshire. That's what most people use it most of the time, and it does it brilliantly. Hello? It'll work in a minute. Right. A whole bunch of things you can do with binaries. Most obvious one is installation. I've just downloaded new piece of code.rpm from my favourite website and I want to install it. And you can just say, install that. You don't need to know where it's going to go, you don't need to know what it's going to do. You can just trust the package manager and in it goes. If you don't trust the person that packaged it, you can actually inquire of it and find out what it is and you can change that. But most people don't. Most people just put it in where the original packager said it should go, and in it goes, RPM -I. How's that for natty? And then you decide actually it's not as good as it looks on the website anyway. So you remove it, RPM minus E, out it comes. I'll give you time to catch up.
It's freshen like too.
Oh, fresh is good. Upgrade's really useful when, particularly when you've got one particular RPM which is part of a dependency tree, so other modules depend upon it. You can't just remove that if you want to upgrade. You can't remove the old one and reinstall, because obviously it will shout that you've now got unmet dependencies, so it won't let you remove stuff that's needed. The upgrade is there to take one module out and replace it with something newer without breaking dependencies. It does things like checking dates, it does things like checking versions, and it checks dependencies. So that does all sorts of nice stuff to make sure that you're doing a safe upgrade. Freshen is much the same. Freshen also will upgrade a set of packages. Where Freshen differs from upgrade is that if you tell it to upgrade a package that you haven't already got, it'll just install it as new. If you tell it to freshen a set of packages, it will only upgrade those packages that you've already got installed. So if you download 28 RPMs and you don't know which ones you need, just freshen the lot. And the ones that you're using will be installed, but the ones that you're not using won't be. Okay, so much for installation stuff. Query is probably the most important thing that the RPM system does. Query gives you simple queries. Is this package installed? It'll give you slightly more complex queries in terms of which version of this package is installed. It'll give you more in-depth stuff. It'll give you who built this package, when was the package built, when was the package installed. It'll give you what does this package provide for me, what does this package do, what does this package need. If there's a piece of metadata about a package that you want, it's usually in a database somewhere, and there are a whole bunch of queries which will allow you to get at it. Read the man page. Verify is important. We've got all this metadata about a package. We know which files should be there. We know which files came with the package. But files change from time to time. So verify is a way of checking through what you've got against what's in the database, against what's in the original RPM. And you can find out what you've changed. So you can tell whether or not the files are as installed or whether they've been modified in some way. That's quite handy. Lastly, the program files, config files and documentation files are all catalogued independently. So you can do things like you can say upgrade this package, and the package management system knows which files are program files and which are config files that you've specifically spent weeks tuning and getting right. So rather than clobbering your old configuration, it will stick its config in with a different file extension. So you'll have an RPM new file extension to say, this is what I would have installed if there hadn't been proper config in there in the first place. Occasionally you need to change the configuration. So remove the old one to, this is what the configuration used to be, and stick the new one in place. All that's down to the original packager. Silence. And that's all the Bible stuff. Let's talk about scriptlets. Scriptlets are the core of the RPM system, really, the bit that makes it something other than just a way to the differentiation between this and a tarball, really. I wish I knew how to work this PC. I just want it. Okay, as I said earlier, there's more to installation than just copying files. Sometimes you'll have additional tasks before you can install them, software, and sometimes you have additional tasks after you've installed it. You might, for example, need to create a database for this to work with. Similarly, if you've got to do other stuff to install it, you probably have to do the reverse of that to remove it. So what we do with RPMs, we have a set of scripts. You've got pre-installation, post-installation, pre-removal and post-removal scripts that you can tell the package manager what to do when somebody wants to install this or when somebody wants to remove this.
So, for example, if you'd installed Apache as a web server, one of the pre-removal scripts would stop Apache, so you can shut all that down.
Absolutely. Yeah. To install the patch, you'll probably want to start it. So post-installation, start the patching. Pre-installation, stop the patching. Sorry, pre-removal, stop the patching. RPM hell we all know about. We've all heard about. What is it? I can bring around for you see next time. Right. I talked earlier about dependencies and RPMs. If you've got a particular package, it will probably depend on a number of others. So, my mind's going to blank and I can't think of anything. You will usually have underlying library type systems you'll need for any given package, so we can keep it modular. So that's great. They contain dependencies. Is this doing anything? Sorry about this. See one go. If you've got an unmet dependency in a package you're trying to install, you have to install packages to meet that dependency. And that means each of these new packages has a set of dependencies. So we can rinse and lather, repeat until we've got them all right. This is RPM hell. This is when you're forever downloading new packages to meet dependencies. And you can sort that manually. It's actually usually not as difficult as people make it sound. But there are other ways as well, of course. You've got, in particular, you've got two programs called apt and yum, which apt is nicked straight from Debian, and yum was nicked straight from Yellowdog. Gotta love that GPL. Apt and yum sit on top of the package manager database. We'll check things like, if I need to install this package, what unmet dependencies have I got? How am I going to solve those dependencies? What have I got to go and get to fix those? And it will do all the recursion and all the sorting out stuff automatically.
Question about Yum. I use Yum. But if you get a package that's not on the repository,
Yeah.
Can you download it and use Yum to install it?
If it's not within the Yum repository, Yum won't do that. But you can use RPM without Yum.
Yes, I know that. I wonder whether the Yum seems a bit safer to use because it looks for all.
Yum makes life easier from that perspective, but if you're trying to put something that's newer than your repository information, you're pretty much stuck there. Yum won't
Yum look at the download.
No, it's quite insistent that you do what's in its repository. But if you put in something that's newer than what's in its repository, it won't remove it for you. It'll work with what you give it. So you just do all that manually. Just use RPM on its own.
You can also add repositories into Yum.
Oh, absolutely.
So if the project has set up a Yum repository, you can add that in so Yum will know about it and will be able to get packages from it and install it and resolve dependencies and do all its stuff.
And you can run your own Yum repository if you're feeling brave.
But the one thing it can't do, it's the same with apps. If you download a .rpm file from a website, Yum won't help you install that. You need to use the RPM command line tools that we had earlier.
So there you go. As Andy said earlier, RPM hell is a thing of the past. This is the interesting bit of RPMs. I don't know how many of you are going to use this part, but source RPMs are, to my mind, even better than binary RPMs. We've so far used RPMs to create a manual binary. Why not use it to manage source as well? You can deliver source within an RPM format. Now, importantly for this, we always start with pristine source. You take the tarball that was released by the project in question, unadulterated, unmodified, exactly as you download the tarball from anybody else. That gives you traceability. You can tell what this is. But frequently, of course, that's actually not really what you want to install. So you can build a set of patches and say, take this tarball and modify it in this way. And the patches go into the RPM. So within your RPM, you've now got the tarball you started with and a set of changes to make it into what you really wanted it. And then, of course, we've got more scriptlets. So scriptlets run RPM, they're brilliant. The important ones, you've got prepare, which will build you a little work area, somewhere to do your build. It'll unpack your tarball, it'll apply all your patching. It can do other things as well, but that's generally what you do with a prepare. Then you've got a compile script, which will go and do the various configure and make and this sort of stuff to build from source to a binary. You've got an install script, which isn't quite what it looks like. Install puts things in the right places, but usually it runs within the build area, so that you can see what would happen if you were to install it on a live system first. And then you've got a build script, which takes what you've installed and puts that into a set of RPMs. Generally, you build a binary RPM with this. You can also, if you've done anything clever, you can rebuild a source RPM using this script. And it's all driven by something called a spec file. .spec is a specification. It tells you how to build things, how to prepare things. Everything you need to know is in the spec file. You've got a change log in there. You've got all your dependencies in there, you've got a list of files in there. Anything you want to do, stick it all in a spec file and you can build an RPM without too much effort. I like source RPMs, you might have noticed. I'm going to draw to close just saying read up on these things, because every time I read through this I learn more stuff. Red Hat have got a booklet thing they wrote called Maximum RPM, which makes it a pig to Google for, so you'll find 100 different car sites. But there you go, it's called Maximum RPM, it's actually a damn good book. There's the URL for it, it's available on their site, it's free, it's a good read, and every time you go through it, as I say, you'll learn new stuff. And that's about all I'm going to say about RPMs.
Okay, are there any other questions?
No.
You happy, James? Anything else?
I'm not familiar with RPM. It used to be the case that there were distribution-specific RPMs. Is that still the case? And
They are still distribution specific. So Mandrake will distribute a set of Mandrake RPMs, Red Hat to Red Hat RPMs. In fact, you'll find, for example, you'll find Red Hat 8 RPMs, you'll find Red Hat 9 RPMs, you'll find Enterprise 3 RPMs, and so on. The package format is identical in all of them. So you could, strictly speaking, you could take an RPM from one distribution and try it on another. But it might not work. Different distributions name their packages slightly differently. So, as an example, some distributions will call it Apache, some will call it HTTPD. So if you've got a dependency, for example, on Apache, and your distribution calls it HTTPD, it's an unmet dependency. Even though the actual code is there, it's an unmet dependency. Some distributions run their file systems slightly differently. Some will put stuff in user bin, some put in user local bin. There are problems if you start moving between distributions. They're not insoluble. You frequently can use them. I mean, on my old Red Hat systems, I had loads of Mandrake packages on there. You can do it. Sometimes there's a bit of work involved. Sometimes it will be getting the source RPM and modifying the spec file to represent the change in the system and rebuilding from there. Can be done.
If it screws the system up, will remove.
Yeah, RPM-IC.
It will it take all the files off the...
If you install a package and it's wrong, you can remove it. That's the whole point of the package manager.
It will take it, it's a Red Hat package with directly control the system.
Yep, if you do an RPM-I and it doesn't work with an RPM-IZ, and out it goes. If you've done an RPM-U, of course, if you've upgraded, you've actually removed your old package first, which means that you may have to find the old one and put it back in. There are ways to do this thing. You can tell it that I want to change this package to that package, and I know it's an older package really, but I really do want to do it. And as long as you tell RPM that you really do want to do it, and you're not just making a mistake, it'll do it. Have I embarrassed myself enough? Or
No, I was just thinking about sort of comparing that with the behaviour of apps on Debian and things.
Yeah, I was just thinking the same thing about depackage and...
Depackage and RPM do things in very similar fashions.
It sounded like they were very... I mean, yeah, they had the same functionality, even if they did things differently.
They're two solutions to the same problem. Yeah. They've both got sight of each other's source code. They're going to be quite similar. Depackage does a couple of what I consider quite strange things, in that it has various status of installation. It can be installed but not configured. It can be partly installed, things like that. I don't really understand why you'd want to do that. So, from the way I think about things, depackage does a few things that I don't like. RPM does things, to my mind, it can be a bit brutal. In fact, it can be a bit go or no go, but it's a cleaner system from my perspective. But then that's just because I'm a bigot. As far as apps are concerned, they're identical. You know, apt was developed on Debian. It's brilliant. So Red Hat nicked it.
And that's what most people use these days. I mean, very few people will install packages using dpackage or perhaps RPM on the command line when there's apps and yum to choose from on the
Absolutely. They're good.
Yeah.
And it's not that particularly in apps, it's really quite easy to set up your own repository.
Are there GUI front ends to package? I don't want to say yum or app specifically, but to install packages in.
Synaptic.
Yeah,
Which
so
is the front end to
apps, yeah. I was thinking particularly with Mandrake or what have you, if there are GUI package managers.
Each distri does anything. Red Hat has got one called Red Hat Config Packages, and their usual
Another one called Yum Extender.
yeah, absolutely. I couldn't get that to work when I tried it.
Yeah, that's quite good.
It looks good, but I failed with it. So
There's a new one called Smart, I think it's just called Smart Packager or Smart. I'll have to look up the URL which I've played with, and that's actually independent of dpackage and RPM, and you can stick it on any system and it will just automatically configure itself based on what sources you've got configured, and that's quite neat.
There's lots of these tools around. We're getting to the point where packages become interoperable. We've mentioned the difference between Debian and Red Hat style things, dpackage and RPM. There's a program called Alien which will convert between them. So you can take one flavour and convert it to the other.
Kills your dependencies, unfortunately.
Yeah, but if you've got source RPMs, so you can rebuild that. You can build your own dependencies. Anyway, we are digressing.
Talking about different types of RPM for different distributions, if you've got a CentOS or a white box installation, is there any significant difference between that and a Red Hat Enterprise machine RPM?
Not in the RPM, no.
Right.
Absolutely no difference. Not strictly true.
I mean,
the source RPMs build in a different place.
Right.
If you're on a native white box installation, all your build stuff when you build it goes in /user/source/white box. If you're on a Red Hat installation, it's in /user/source/Red Hat.
Right.
If, like me, you use a lot of Red Hat source RPMs on a white box installation, you run a symlink. They build where they want, but it's the same place. But the packages are absolutely identical. So yeah, for something like I use Whitebox. That's my installation. I get all my updates from the RHN errata page. I download the source RPM straight from Red Hat's FTP site, and I build it. I usually build it on somebody else's machine because it's quicker.
Were you thinking specifically about packages that are produced from companies who say, we support Red Hat Enterprise, but you can just take the RPMs that they produce and run them on Whitebox?
To a certain extent, yeah.
With a very few
I wasn't necessarily expecting to get support from them if you told them you use Whitebox, but whether or not they would actually be usable.
Usually you can. With a very few exceptions. There's lots of scripts involved in installations. Some scripts check for Red Hat specific files.
Right.
So, for example, you might look at /etc/issue and check for the Red Hat name in there. And if it said Whitebox instead of Red Hat, it won't know it's the same thing. So, if somebody's not built a very clever installation script within their RPM, then you might run into the occasional problem. But the vast majority, well over 99% of packages, no problem at all.
Cool. Any more? No? Okay, thank you very much indeed, Dick. Very good.